So, good morning and welcome on this beautiful sunny day to the next installment of our Flood Innovation webinar series on sustainable drainage systems, brought to you by the Flood Innovation Center. Today, I will be joined by Dr. Kate Smith, who is one of the Flood Innovation Center team, and she is also a researcher in flood resilience, focusing on the human impacts of flooding. Following Kate's introduction, you'll hear from a couple of experts from the University of Hull, Dr. Rob Thomas, who is the Senior Research Fellow in Geomorphology and Flood Risk, and the Deputy Director of the Energy and Environment Institute, Stuart McClelland, and they're going to give you a scientific overview of why we need some innovative drainage solutions. After that, there's going to be a presentation from Green Blue Urban by James Dalrymple. He's joined today by Howard Gray. They're going to be giving us a very well-informed overview on some of the products and technologies available in sustainable drainage systems and the merits of those products. And then next, we're going to have hopefully an excellent insight into the market for sustainable drainage in the Hull region. From the flood risk manager at Hull City Council, Rachel Glossop. And lastly, you will hear from me, and I'll tell you how the Flood Innovation Center can help you get involved in this fantastic growing market. So while many of our presenters are Hull-based presenters, we do represent the Humber and transition regions. And there are significant flooding issues throughout the whole Humber region. So just want to make sure that we understand that we do include in that the effects on the whole region, including North Lincolnshire, North East Lincolnshire, and all East Riding of Yorkshire. We're going to follow all that up with a Q&A session. The panel will be available for that. However, if you would like, you can ask questions throughout the webinar using the Q&A button at the bottom of your screen. And any available panel member will try and answer your questions. If you have a question for a specific panel member, please make sure to include that in the text of your question.
Last year showed us that flooding continues to be a really significant risk in the UK, despite major investment in flood defences over recent decades. Our vulnerability to flooding is increasing due to global temperature change, more extreme weather, sea level rise, and changes to the way that we use our landscapes. The hazards presented by flooding have many different causes and solutions. Sometimes they're caused by rivers, by rainwater at the sea, but the impact of floods extends well beyond the immediate threat of water being in the wrong place. Its effects are felt long after the floodwaters have receded. The way that we respond to flooding needs to evolve alongside the risks. These are evolving more rapidly under climate change. We know that we can't keep on building higher and higher flood defences, so we need to find more innovative ways of dealing with water before it turns into a flood. Natural landscapes have lots and lots of different ways of coping with water, but once we start urbanising, farming, draining the landscapes, putting in sewerage systems, those ways of coping can become much less effective, and water starts to be a problem, as you can see here. Our hard landscapes don't do a good job of absorbing or adapting to heavy flows of water. Drainage and sewerage systems, which are buried beneath our streets and pavements, can only carry a limited amount. In extreme rainfall events, this old infrastructure often can't cope, which leads to sudden and often unpredictable flooding. The impact of future flood events on our lives, economies, and communities depends on how well we plan and build for excess water now. This means we need to take an innovative approach to the ways that we think about and manage water for the future. One of many solutions that's been pursued by planners, flood mitigation authorities, and researchers and engineers is widespread implementation of sustainable drainage systems, or SuDS. SuDS can look like many things. As well as providing space for water, they can provide habitats for aquatic and marginal plants and animals. They can bring rich ecosystems into the middle of our towns and cities, as well as giving a space for water to flow and be absorbed safely. They can shape outdoor spaces for humans and nature to thrive together. We all know now why flattening the curve is important for reducing the impact of major incidents, and this works for SuDS too. SuDS slow the flow of surface water. They can catch and hold water in places that are less likely to be impactful, like this aquagreen, which can drain away slowly and safely. Often, SuDS are invisible at the street level as they're placed beneath the surface. These blocks act as an aquifer which can collect water when large volumes come into the system all at once. This helps to stop the drainage and sewerage systems becoming overwhelmed. Above ground, SuDS can provide a focus for commercial and residential amenity spaces to be improved and redeveloped. By supporting plant and animal life, they create valuable natural spaces which also serve a really important function in reducing flooding downstream. SuDS are all around us already in many cases, often replicating the multidimensional environments that were found in natural landscapes. Smart planners and landscapers already provide vegetation-rich paths to slow the rate at which rainwater reaches drains and sewers, for example. SuDS can also be a way to bring communities together to become more flood resilient. In Portland, Oregon, in the USA, planners have actively involved citizens in planning and building SuDS schemes, resulting in widespread support and understanding of how the system works and to help manage surface water flooding. Humans have always lived alongside water, and our ancient cities had their own ways of living with water, either to conserve it or manage water flows. These are 13th century drainage channels from Freiburg in Germany. They're now a tourist attraction in their own right, and they still work. But sustainable drainage isn't just about channels and catching water. It's also about getting water into the ground. We've paved over lots of permeable natural surfaces. Hard surfaces cause water to form pools, which results in rapid runoff. Making the switch to permeable paving reduces this. We need innovation to make these kinds of pavers cheaper, more sustainable, and easier to retrofit. There's lots of potential for SuDS to improve our domestic resilience and how we live with water too. Though they seem small, property level changes such as collecting rainwater, creating swales and rain gardens, or using green roofs all contribute to slowing the flow and reducing flood impact, particularly in built-up areas. The aesthetic impact of sustainable drainage is also really important. Beautiful, dynamic spaces which are well designed contribute to improving people's well-being. Making space for water in our gardens or outdoor spaces contributes to their appeal, as well as making sense for flood resilience. Investment in creating accessible, well-designed, beautiful open spaces delivers excellent social value. High-quality, accessible open spaces improve community well-being across the board, as well as increasing flood resilience and biodiversity. As well as increasing flood resilience, SuDS have other environmental benefits too. They can, for example, help to mitigate urban air pollution and temperature hotspots, another aspect of climate change that's going to get more challenging even for us in the UK. If implemented carefully, SuDS can filter the amount of pollutants that enter rivers and therefore the sea, both chemical pollutants like the runoff from agricultural processes and physical pollutants like plastic waste that breaks down to form marine microplastics. The broader ecosystem services offered by well-designed SuDS bring multiple benefits in addition to flood resilience. Particularly in contexts where hard engineering solutions can't or shouldn't be used, they offer a realistic economical solution for building resilience to future floods.
Thanks, Kate. Good morning, everybody. I thought that I would start by talking about what we mean by the word risk. Here on the left, we have a natural system represented by the orange circle, in which events such as floods are a potential hazard. And the human system, represented here by the two blue circles to the right. The human system can be defined by its exposure to hazard, that is, whether people, property, systems, and so on could suffer losses, and its vulnerability to that hazard, that is, the characteristics and circumstances of people, property and systems and so on that make them susceptible to damage. Vulnerability can therefore be seen as the opposite of resilience. This slide shows that hazards such as floods are not inherently risky unless they impact upon society. Risk therefore arises when vulnerable people, property and/or systems are exposed to hazards. Furthermore, as hazards get more severe and society becomes more exposed and/or vulnerable, risk increases. If we can reduce exposure or increase resilience, we can mitigate risk. Otherwise, there is scope for enormous losses. In England, the Environment Agency defines risk purely in terms of exposure. 5.2 million properties are exposed to flooding, with 2.7 million exposed to river and coastal flooding. 3.2 million are exposed to surface water flooding, and 660,000 unfortunate properties are exposed to river, coastal, and surface water flooding. The Humber is the second most flood-prone region in the UK after London. 44% of residential properties and 50% of non-residential properties are exposed to river and coastal flooding. The Humber is also exposed to surface water, sewer, and groundwater flooding. Hull epitomises why this is the case. It is vulnerable as the third most deprived local authority in the UK, and is also exposed, with 92% of residential properties and 95% of non-residential property exposed to river and coastal flooding. Hull is also at risk from other forms of flooding. Here is an aerial photograph of Hull, and I'm going to overlay the city boundaries as a visual reference. Then I'm going to overlay a simplified elevation map of the city. On this map, the areas shaded magnolia are higher areas. You can see that Hull is basically a bowl with only one outlet for water to the east of the city. The lowest points here are less than 50 centimetres above average sea level. In addition to the river and coastal flooding I showed just now, you can see that rainfall would just accumulate in the bowl. In addition, water can run down from the hills to the west, and drains and sewers from our streets and housing estates connect to the sewer network that only has one outlet to the east of the city. On top of all that, Hull is built on a thick clay cap that lies on top of a chalk aquifer, so it is also susceptible to groundwater flooding. So that is the situation today, but what does the future hold? 4 degrees C case shown in these graphs shows our current best estimate of increased sea levels, increased high intensity rainfall, and increased river discharges. In the graph on the left here, we can see that by 2060, average sea levels at Immingham are expected to rise by 37 centimetres. By 2100, this is expected to be 65 centimetres. And remember that the elevation of the lowest points of Hull are less than half a metre, 50 centimetres, above sea level. Rainfall intensities are expected to increase by 20% by 2060 and by 50% by 2100. Furthermore, peak river discharge are expected to increase by 21% by 2060 and by 31% by 2100. Now, so far here, I focus on our best estimates, but current scientific expectation is that what eventually will happen is going to be worse than this. For the worst case H++ scenario, sea levels are forecast to rise by 60 centimetres by 2060 and by 1.45 metres by 2100. Rainfall intensities are forecast to increase by 35% by 2060 and by 70% by 2100, and peak flows are forecast to increase by 90% or nearly double by 2060 and 178% or nearly triple by 2100. This scenario is what we are faced with unless the world acts to limit and then reduce greenhouse gas emissions.
Thanks, Rob. I'm Stuart McClelland, the Deputy Director at the Energy Environment Institute, and I'm just going to follow on from both what Rob and Kate were talking about and say something about how sustainable drainage systems are attempting to intervene in how the hydrological cycle sort of operates. So following on from what Kate said, if we think about the urban water cycle, what's happening is that we are reducing the interception of water, we're reducing the amount of water that infiltrates into the soil and down into the groundwater system, and reducing percolation. All of these processes are basically reducing the slow pathways that water can move through a catchment with, and instead force water onto the surface and to move along faster pathways, giving more surface runoff, which reaches rivers quicker and is what enhances the flood risk. At the same time, it has negative impacts on the groundwater system, reducing the amount of water available in aquifers, which reduces the base flow levels of rivers, and that also has ecological impacts. So the changes that we make within the water system by urbanizing and developing catchment systems have a significant impact on what the flood risk will be. And the whole idea of sustainable drainage systems is to go back to a more natural water cycle. Next slide. So what we're trying to do in terms of sustainable drainage systems is to restore back towards a natural water cycle system. And by doing that, what we're trying to do is basically have more vegetation in the system so that we get interception of rainfall. That reduces the rate at which water reaches the ground surface and slows it down. That allows there to be more infiltration into the soil, allows more water to percolate into the bedrock, and basically slows down those transmission pathways that water moves through the system. So we're trying to increase evapotranspiration, reduce the amount of water that we actually have to deal with, but also ensure that the water moves much more slowly through the system. That also contributes, if we have higher groundwater flow, to more continuous flows within rivers, which again has these positive ecological benefits. Next slide. So looking at a flood hydrograph, which is how we describe water flowing through a river channel system, the graphs at the bottom there, the vertical axis describes the amount of flow in the river system, and the horizontal axis is describing the time after the rainfall event starts. And in a natural system, so the example of the blue line on the left-hand side, we have higher base flow initially when a rainfall event occurs because we have water flowing slowly through the groundwater system. But most importantly, the peak from that rainfall event is going to be lower in height, and also the water will be distributed over a longer period of time. So we get this flattening of the curve and this flat hydrological response. And that reduces the amount of risk that we're going to have from a flood event. And what the problem with urbanization is, and what we're trying to deal with in terms of sustainable drainage systems, is that when we urbanize a catchment system, we're basically producing these flow paths where water moves very quickly across the surface, very quickly towards the river channels. That makes the flood event much shorter, so the water is delivered to the river channel much quicker, and this is what the red curve is showing, but also the peak flow is much higher, and that's what really leads to the larger flood risk. Next slide. So in terms of moving to a more sustainable urban water cycle, what we're trying to do is reintroduce into our urban systems, into our developed catchments, ways in which the water can flow through those slower pathways. So we're encouraging infiltration into the soil so that we get more flows through the bedrock. Where we do have contaminated runoff, we're looking for things like wetland treatment systems, which are basically a buffer between the rain falling on the land surface and it getting into our river channels. Again, as Kate mentioned, that gives us significant ecological benefits, but it slows down the rate at which the water gets towards the channel. And it's all about slowing down the rate at which water is flowing through the system to reduce the height of that flood peak and reduce the hazard and risk from flood events. Next slide. So what can SuDS do to make the urban water cycle more sustainable? Again, if we look on the left-hand side here, when we have a precipitation event with water falling onto a catchment, we have a lot of the water we're hoping to remove through evapotranspiration and infiltration and a relatively small amount of runoff. But if we look at urban systems, we completely transform that hydrological system. So that precipitation has more pathways in order to move quickly into river channel systems, and we get reduced infiltration, reduced evapotranspiration due to the hard surfaces in our urban areas and less green spaces. But we also have the impacts of wastewater and imported water adding into that environment. So there are additional pressures on that urban water balance. So if we're looking for sustainable drainage systems, what we're trying to do is change that water balance. And again, produce more evapotranspiration, increase the amount of infiltration, provide routes where we can treat that stormwater and reduce the pollutants entering river channel systems, but also maximise the reuse of water within our urban areas so that we're reducing the pressure on our river channel systems. Next slide. So in conclusion, from what Rob was showing us, it's very clear that the Hull and Humber are exposed to significant flood hazard, and that hazard is going to increase in the future. All the predictions from climate change show us that flood risk will increase. Greater urbanisation will increase the pressures on our water channel systems. So we need to adapt. We need to try and reduce the exposure to hazard, reduce our vulnerability by enhancing our resilience. And one of the biggest ways that we can do that practically is to try and effectively slow the movement of water through our urban areas and reduce that flood risk. Thank you.
Hello, good morning everyone. I'm James Dalrymple from Green Blue Urban, but what I'm going to speak about briefly is the positive impact that trees and green infrastructure can have on managing stormwater runoff. So in effect, trying to recreate the natural water balance, which is what we've just been hearing of. Next slide. Now, I expect most of us have sheltered under a tree at some point in our lives. Always have to be careful just in case there's an electric storm, but they do have wonderful interception capabilities. And this was a snapshot I took a year or so back. It's a lovely tree in central Manchester, and there was a sharp storm, and as you can see, there's a very distinctive rain shadow around the base of that tree. So in terms of what that tree is holding back, researchers proved that around about 70% of all the water which falls on that canopy during the first hour of a rainfall event actually never reaches the ground. So this is, I thought, a great slide that everybody can see. You don't need to be a drainage engineer to spot the great big dry patch underneath that canopy, and we'll probably shelter under trees going forward. We'll move on to the next one. Now this is a short animation. This is, we're just going to have a very quick look at what goes on below ground and all the benefits that a tree can bring. So here we've got, you'll see in a second on the right hand side, we've got water falling on typically a roadway, and you'll see it, it's a little bit jumpy on my screen, but you'll see it entering typically a curb flow inlet. The water then builds up in the silt trap, which is just to the left of the curb flow inlet. That water then runs across the top of the tree pit and down through the soil medium. And we've seen it just filling up in what we call the arbor flow panels surrounding the tree. We can also use the air vents for water inlets as well. Additional storage can be provided above the soil zone, depending on what your catchment area is, if you need additional storage. Permeable paving is also a great idea to use above tree pits because it distributes the water very evenly. And in the event of exceedance flows, we can direct the water to a very permeable surface immediately around about the tree. The main benefits of this system is that the rooting medium is acting as filtration medium for the water. It's slowing down the peak runoff, and you can infiltrate back into the ground in addition to actually piping it away into your storm drain. Now, I thought this is a lovely example in West Yorkshire. This is a project which went in a couple of years ago. This is a highway realignment project, and one of the aims of the project was to significantly reduce the stormwater runoff. So what we can see here is a tree pit trench during installation. You can see the structural crates. They're very, very strong. They'll take vehicle loadings. They're manufactured in the UK from 100% recycled material. So they get filled with soil, and you can see the metre square apertures. That's exactly where the trees are going to be planted. At the very base, there's a stone drainage layer, which has a perforated pipe, which will collect any excess water, which eventually finds its way down there, which will be very, very minimal, particularly during the summer months. If we move on to the next one. There we go. Now, I had reason to be up in Keighley a couple of weeks ago, and I took this shot. As you can see, the trees are looking extremely healthy. You can see from this angle that there's quite a significant catchment area in terms of impermeable highway on the left-hand side, and you can see the gaps in the curbs. Now these gaps are quite wide, so they're not going to get blocked by crisp packets or Coke cans. And what we can see there is evidence of silt running off on top of the stone mulch layer, and that silt will actually bring quite high organic content, and it'll be quite full of nutrients. Pollutant loadings, it looks like to me, are pretty low because the weeds seem to be growing really successfully there. So in the summer months, those trees will be using up the vast amount of water. So every time it rains, those trees are loving it. In terms of things like de-icing salts, we don't need to worry too much about those because they will be just constantly being flushed through. If we just move on to the next one. This is a slightly more close-up look at the inlets. As you can see, there's a bit of weed growth there, which I think again is good evidence that there's not very much in the way of nasties in there which are going to cause a problem to the tree. You can see the local authority have put a trip rail around. They just don't want people stumbling in there because there's a bit of a drop off from the curb because the water needs to come into that inlet and just drop down onto the stone mulch layer. We'll move on to the next one. Now this again is another short animation. In some situations, we just don't have the physical space to get a tree. So we've developed a product called the Hydroplanter, which is a plug and play rain garden. So very simply, you dig an excavation, you connect it up to a positive drain at the outfall, and they're supplied in individual units, or you can link them up together in a linear run, however long as you like. So you can see them being installed. The drainage pipe at the base extends along the length. We then surround that with a stone drainage layer. We put a separation membrane in. We start backfilling up the outside with a stone, typically type 1. We fill up the middle, obviously, with the growing medium, which is also acting as the filtration medium for the soil. We then put a small concrete surround around the top, help it keep its form. And if we're installing the system on a slope, we can install these weir walls, which will obviously prevent erosion. And then we can see the, oh, that's gone. I think I must have a slight delay on my screen, but hopefully everybody else saw the inlets for the water. Now this project here, this actually, what we call Grangetown, actually led to the development of the planter, the Hydroplanter. This was a significant size retrofit project in Cardiff, in the city centre. I'm not going to go into detail now, but they were experiencing huge combined sewer overflow instances, resulting in just having to take a lot of water out of the combined sewer or increase the size of it. And the options to increase the size of it were extremely expensive. So we looked at the incorporating green infrastructure, and we managed to put this system in at approximately a tenth of the cost of the engineered solution, if you like. So if we just move on to the next slide. So as you can see here, this is after it's all been installed. We were very restricted in terms of space because parking was at a premium. So a lot of the soil volume for the trees actually extends underneath the hard paved areas. In terms of some of the statistics, the actual site area where we managed to, the impermeable area we managed to remove the runoff was in excess of 15.5 hectares. It was about 14 streets. And each year we're removing over 40,000 cubic meters of water from the combined network, and we're putting it through the rain gardens and we're discharging it straight into the River Taff, which is just behind that wall, which you can see in the background. If we just move on to the next one. Looks like this is the last one. This is just a little close-up as to the inlets. So we've got water draining off roofs, pavements, roads, finding its way into these inlets. There's very strategically placed overflow events, which in the event of really severe storms, it prevents the whole thing backing up. But I've actually been on site during heavy, heavy storms, and there's just no hint of it heading anywhere near the overflow. So is there one more slide? Super. That's me done. Thank you.
Hi, I'm next on. My name's Rachel Glossop. I am the Flood Risk Planning Manager at Hull City Council and one of the partners in the Living with Water Partnership, which also includes East Riding of Yorkshire Council, Yorkshire Water and the Environment Agency. If you could move on to the next slide, please. So what I'd like to talk to you about really, we've heard quite a lot about SuDS, we've heard about some type of SuDS that we could use. I want to really talk to you about the gaps we feel there are in the local market, which are specific to Hull and the surrounding area. So we've already touched on this, but I'll just go back over it, a bit of an introduction to Hull really. So as we've discussed, it's a city built around water. Its topography is shaped as a bowl. You've got 90% of it below high tide level. 20% of England's land drainage actually comes down the Humber estuary, which I don't think people realise. We just look at the Humber estuary and we don't really appreciate the scale and the size of it. 84% of the surface water in the city and surrounding area is actually draining to the sewer system. So there's little in the way of sort of natural outfalls to watercourses, and we are 100% reliant on pumping. That situation of being shaped like a bowl means that to get the water to discharge means that we have to rely quite heavily on pumping systems. And of course, this also means with the challenges of climate change that we're going to have to rely more and more on pumping, because as sea level rise, it means that we'll be more subject to tide locking. So in terms of surface water, we're going to have to store more and more of it because it's not going to be able to discharge effectively. You might ask, having heard all of this, why on earth would you build a city in this location? Well, that would be fine if we were thinking about designing cities. If we had a blank slate as a country now, we maybe wouldn't be locating cities where we have located them. But of course, we have done that because settlements were built around water. Water is crucial for trade, wealth, it's a resource. And so that is where most of our cities, if you think of most places in the country, they are usually based around water. And it's now, with the challenges of climate change, that we're having to face up to where we've historically located our cities. Next slide, please. So I wanted to put this slide in because this is traditionally how we've managed flood risk. This is looking at a pub that's down in Essex, so it's obviously not in the Humber estuary area, but it's typical of the ways that we've managed flood risk across the whole of the UK, well, across the world. And that's to build walls higher and higher. There's only a certain height that we can get to for this. And when you look at this, is this really sustainable? The consequences of this wall breaching or overtopping is absolutely fatal for this pub. You can see that the height of the wall is almost at the roof height of the pub. Therefore, as soon as you get any sort of breach or overtop, the velocities of and the depth of water that you could expect in that building is going to cause fatalities. Therefore, we really have to think about managing flood risk in a different way, which is hence why we formed the Living with Water Partnership, because ultimately to be able to manage flood risk in the future, we need to think about living with it, we need to think about adapting to it and accepting that water is going to be in our cities and around us, but we're going to direct it to where we want it to be. So that's where it can do the least damage. So it's about using sustainable drainage systems. It's about using roads as conveyance. It's about using green open spaces to store water and really directing that water away from property. Next slide, please. So this is the different vision. This is the Living with Water approach. So it's really about involving communities. The easy thing about building walls and about building pumping stations and the traditional engineering that we've done in the past is that you haven't really needed community buy-in. And that's very apparent when you think of people's perceptions around flood risk. They always feel like it's not something that they're responsible for or that they need to be involved with because it's something that another authority is going to deal with. This isn't going to be able to continue. We are going to have to all think about flooding in a different way. If we're going to become adaptable, resilient cities, then it very much has to be involving communities, and it's going to be much smaller scale. So instead of it being a large flood defence scheme that's built perhaps somewhere in your city, but not something you see every day. We're talking about solutions which will be street by street level. People will know about it. It might be like the example that was shown just previously in Cardiff. I know that involved taking parking spaces in streets and things to retrofit some of these sustainable drainage. People need to realise that there's a reason for that, and we need to work on that. So it needs a completely different approach to what we've done in the past, and it needs to be completely working with people. Next slide, please. So this is where the two things have to meet, really, and that's what we're working on with Living with Water. It's very much working on the community involvement so that we have people demanding more blue-green infrastructure. And that's particularly relevant at the moment with the current situation we've just been in. How many people in lockdown without gardens would have just loved to have that green infrastructure so close to their homes rather than having to walk a mile or so to the nearest park? It's something that's quite relevant, particularly at the moment, and a lot of people are sort of thinking about that. And what we're wanting to do is two things. So we're trying to bring the community up so they're realising the benefits of this blue-green infrastructure, while at the same time trying to create the market so that we're ready to be able to fulfil people's demands. So next slide, please. So really this leads on to the drivers, the local drivers really for us. So I've discussed about that fact of, I feel at the moment we're at quite a crucial time where people are actually starting to really realise the benefits of the green space around them. We've got a joint supplementary planning document with Yorkshire Water. So this is the only one in the country that I'm aware of where a local authority has actually agreed with the water company a discharge rate from all new developments. We've got that down in a supplementary planning document, and that really pushes developers to be implementing SuDS, and particularly when I say SuDS, talking about above ground green SuDS, so more of the planting rather than just below ground oversized pipes or tanks, which is what tends to happen a lot at the moment. The planning process really does push for SuDS. Since I think it was 2 years ago, the National Planning Policy Framework included some new guidance on there that really is pushing developers towards that implementation of SuDS. It has to be part of a new development. The issue at the moment, and this is nationally, not just locally, but we do see a lot of examples of this locally, is that drainage tends to be added into a new development at the end of the process. So a developer looks at a site, works out where his houses are going to be, works out the density, and then adds in the drainage as an afterthought. Whereas if you're looking at this and putting SuDS at the heart of it and seeing all the benefits of SuDS, so not just as a flood tool, but actually as a tool that creates water quality, that also provides amenity value and helps people's health and well-being, and provides the habitat and biodiversity that we're looking for, then that needs to be planned in at the start, and then your development builds up around this. I put there about community scale rainwater harvesting and grey water reuse. I just find it ironic that we've been through one of the wettest winters in record, and we're now going into drought, and nobody's thought really about storing water. So people are watering cars using tap water. In agricultural areas, there's irrigators being switched on right, left and centre. There's no thought in this country really of actually holding water back and how we're going to use that. And water is an infinite resource. I think we're also used to turning on a tap and the water being there, but the price of water is only going to, as the demand for water increases and the lack of water, which we know is a real issue in some areas, is going to come ahead. This water is going to get more and more expensive, and it's going to be a critical resource. So it's really important, and this is quite prudent actually for the south bank of the Humber, that people think about storing water and using that water as a resource, rather than when we have a flood, let's just get rid of it as quickly as possible and then never see it again. I've got there about highways retrofit for conveyance and storage. So that's as I said previously, it's about sort of using our roads differently. It's about really thinking about those multiple benefits. We actually did a REBA design competition for living with water. So this was about creating a development that really embraces this concept of living with water. So it was about having the flood resilience built, but it was also about those sustainable drainage systems to really try and improve people's lives. And we've also got the Pathfinder Property Flood Resilience, which is some officers working with us from City of York Council. And across Yorkshire, we're sort of looking at community perceptions of flood risk and SuDS and how that can improve people's lives. And just, again, building on this community involvement, because one of the big drivers in this, the planning process, is what I see as the stick, but the community is actually demanding more sustainable drainage, which I feel is coming. That's going to be the carrot. And that's the thing that we really want to work on that. So if you could just flip on to the next slide, please. So I've worked in this industry for quite a long time. I'm not going to tell you my age, but believe you me, it's quite a long time. And there really is a gap in the market. SuDS is actually, it's multiple benefits. So it actually requires multiple skills to actually design and implement SuDS that work. And that's quite hard to find, because we tend to in this country have people that have specialized skills in ecology and planting, and then you have people with specialized skills in drainage engineering and particularly engineering, but it's linking all those up to those people. And it's sort of urban design. It's getting in at that early stage and being able to design it into your developments. I feel that's a gap in the market. So that's sort of maybe through the consultancy side of things. There's innovation. So very much we're very keen to link things, sustainable drainage, up with smart technologies, because I feel that really helps communities feel that they're involved, even just down to having a sensor in the water butts, which links to an app which tells people how much water's in the water butt and when it needs emptying. And they can then link that in with all the Met Office apps about weather warnings and things. It's really trying to encourage everybody to get involved with that type of issue. We have a lot of local issues. I think already on the Q&A there's been quite a few questions about the fact that in Hull, soakaways are not suitable. My team, we are the statutory consultee from the lead local authority perspective on planning applications for drainage. We say flat out, don't even go there and do your borehole testing and your soakaway test, infiltration test, because we know that we have that heavy clay soils in Hull. There's very little infiltrates into the ground, and then actually in the areas it tends to be near where we have our aquifers, which we use for our drinking water supply. So there's regulation there then about what's going into that groundwater. So we've got interesting soil types, which adds challenges, but it also, I think, brings opportunities to look at different ways of doing things. The topography is very interested in Hull, as we often say, it is like a bath with higher land surrounding and one plug hole, which is the wastewater treatment works to the east. And that sort of brings its challenges. It means that things are discharged into the sewer system, which is why we work so closely with the water company. So your sort of discharge point is going to be going into that sewer system, and all of these things sort of dictate the systems that's used, but there's also is a lot of room for innovation in that. We do tend to find that there's a lack of local manufacture of products, and that can come down to water butts. I know we were looking for somebody to help manufacture some of the water butts recently, and we did really struggle to find anybody locally who were able to do that. The last thing I want to do is have to buy a bulk order of water butts that are really coming in from China, when I'd much rather be able to get somebody to be able to manufacture them for us locally. And again, same with lack of local workforce. So we've retrofitted quite a few sustainable drainage systems in Hull, in our green spaces and in the areas. And when I put the work out to tender, it's usually the same company that gets the contract each time, because there's very few other people actually come back on it. So, and the last one there was about maintenance. So maintenance of SuDS has always been an issue. There's something out now called the Codes of Adoption, which means there's much more scope there for water companies to maintain, but that doesn't mean that's the only solution. And there's sort of management companies all looking at innovative ways to maintain SuDS. You'd be on a winner, because it's a massive issue nationally. Maintenance of everything is a national issue, but maintenance of SuDS is something that's always an issue with that. And I think last slide, please. So this is just a video that we've created with Living with Water, which is about the art of the possible. So it's sort of the vision that we'd like to see of a city. We would like to see a city, obviously, that's resilient to flooding, that's adaptable to climate change. I'm not going to show the video because it's sort of about 8 minutes long, but please go and have a look at it. It is quite interesting. But just the image on here was just something that this is how we sort of see parts of the city, certainly, being like in the future, because we won't be able to keep the water out. So we are going to have to look at innovative ways to let the water in. And that's it. Thank you.
Thank you very much. Can everybody hear me? Yeah, thank you very much. First of all, I want to say on behalf of the Flood Innovation Center, thank you so much to Kate, Rob, Stuart, Howard, James, and Rachel for contributing, giving this excellent background and overview of sustainable drainage systems and the current state of the drainage in the whole region. As you will now be aware, there's almost unlimited entry points into this sort of growing market. It could be engineered products like geocellular modules or discharge valves, water butts, or electronic products such as sensors, communication systems, monitoring systems. There's also services, as Rachel mentioned, of excavation, installation, and maintenance of sustainable drainage systems. And it's not just a growing market, but it's also a market that's here to stay. We're a long way off from sort of solving the flood problem, if that's even a possibility. So getting into this market, it's a nicely sustained market. And like Rachel, we at the Flood Innovation Center are very interested in filling those gaps in the market with locally produced goods and services. Our primary objective is to support any innovations around flood resilience, and to help get those to market, to help businesses in the region to thrive by commercializing things, products and services more rapidly. We want to grow and maintain also this collaboration ecosystem where we're working together with the university and businesses and exchanging knowledge. And we want to grow that ecosystem in a way that it is sustainable as well, and it carries on even after the projects are finished. So the areas that we're mainly supporting are the Humber region, but also any transition regions in England. If you don't know whether or not you're in the transition region, we can help you to discover where you're actually located. So the Humber region, the whole region, including, like I said, Northeast Lincolnshire, North Lincolnshire, and the East Riding of Yorkshire, are all experiencing this heavy flooding, especially at peak rainfall times. So we're supporting that whole region with our program. And that extends to small and medium-sized businesses. And it can be businesses that are maybe just wanting to add some sustainable drainage services to their offering, or maybe they want a business that would like to try and enter this market through, say, installing sustainable drainage. Or it can be companies that have completely novel ideas and are bringing something entirely new to the market. And we can support anywhere along that stage, from a well-developed idea almost all the way through to commercialization. So, for example, if there was an engineering firm who designed a new type of flow regulator, we could support them by helping them to test those under realistic simulated environmental conditions with flowing water, and see how that product performs. and help them to, incorporate effective design changes. Or if it's, an earthworks company that is just really interested in getting bidding for some of that available work through the local authorities for these larger infrastructure projects, maybe helping that company to understand the market a bit better through one-to-one technical discussions, or perhaps through a technical workshop on that subject. So we've got multiple resources to support a broad range of projects, which I've got listed here. So we've got our hydrolab testing facilities, which, like I said, we could simulate the a flooded environment. That would be really good for performance testing products. We can also do proof of concept prototyping and further testing of those prototypes. Some of our prototyping capabilities include design and build of printed circuit boards, electronic circuit boards, and 3D printing in various materials. And then we can then take those prototypes and test them as well. We do support collaboration. That is one of our main objectives, is to sort of get involved in this knowledge exchange, get businesses working with the university, so there can be that two-way exchange of information. Businesses can benefit from the research that's being done at the university by the experts, and the experts can be informed in the direction of their research by those businesses as well. We can also support in the supply chain, helping to source materials, or help a business to find their place in the supply chain, and help with those business processes that will support that. Digital modeling is another thing that we can do. There's quite a few resources at the Energy and Environment Institute for modeling flow through the environment, through the systems, and different ways that we can look at that to support the development of products, especially around SuDS. I can see that actually working really well. If someone had an idea for a new way of developing a new way of managing flow through a particular system, digital modeling would be a great way to support that package. We also will be doing workshops at the moment. They're all on the internet, obviously, through webinars, due to the current situation. However, once the lockdown ends, I suspect we will be maintaining some of our webinars so that we can reach a broader audience, but also we'll be doing some in-person workshops. Some will be small, some will be large. They might be sector or technology based, but look out for those through our usual channels. So our support is completely free and can include, if needed, up to £20,000 worth of consultative support or use of facilities and resources. So it's an excellent thing to get involved in if you're a business. So, and the way that we do that, the way that you can get involved, is to first get in touch with Liz Johnson, who is our Business Development Manager, and she is also on our panel today, along with Pip Betts, the Project Manager, and two of the other technology research managers, Chun and Elena, are all on the panel today as well, if you want to ask any specific questions about our program. If you get in touch with Liz, she will likely send you out this registration form. The registration form is super easy to fill out. You can do it on your PC or Mac. It does not need a wet signature, so it's an excellent thing to do right now, while we still can't meet face to face, and while it's difficult, to say get to the post office. It's something that can help us get the ball rolling. It's a way to get your business sort of moving in the direction of innovation while we're still in lockdown. Because once we get all the eligibility checks out of the way, we can begin a project. And ideally, we'd get those eligibility checks out of the way now, so that we can resume, once we resume business, we can get started on that project, scoping and specification, immediately. So please do get in touch with Liz. Her details are on the screen. You can get them from through the university website as well. Okay, so Now we're moving on to our Q&A. So I am going to first read through the questions that have already been asked and the answers to those. And then if any new questions come up, then we will go ahead and I'll pass those on to the right person to answer. If you have a specific question aimed at a specific panel member, do please put that in the in your question text so I know who to aim it at. Okay, so the first question is from Paul, and he says, in a city like Hull, the water supply comes from the chalk aquifer. Therefore, we have to be careful that any water put into a soakaway does not contain pollution like hydrocarbons. Is this considered in SuDS design? That is a great question, and one of my favorite features of SuDS design. Firstly answered by Rob. Hi, Paul, you're correct, but the geology also works in our favor. The chalk is capped by a thick clay layer, which is very impermeable. So in many cases, as long as SuDS are built within that clay layer, the water transmission won't be sufficient enough to create a problem. Excellent answer. Thank you, Rob. Also, because of that, Rob goes on, and because hydrocarbons are lighter than water, they generally float to the surface. And Stuart adds, this clay layer has been used in the surface water stores that have recently been constructed around the city of Hull. So these stores just retain water and drain slowly into surface water after a rainfall event with minimal infiltration in this case. Thank you for those answers, Rob and Stuart. The next question is from Bill Blackledge. SuDS can be much more than plastic in the ground and can be considered considerably cheaper than plastic in the ground. And Stuart has replied very accurately, yes, we do need a diversity of approaches. And I think that's where the Flood Innovation Center certainly comes in. And we definitely want to support that diversity of approaches and innovation in the area of sustainable drainage. Okay, and a question from an anonymous person. Sorry, thank you for that question, Bill. For green blue urban, how are your crates planters managed at their end of life? Can they be reused, recycled? Also, is there a risk of the plastic breaking down in service, resulting in microplastic pollution when water is discharged into rivers and streams? Okay, thank you for that question. And James replies, hello, thanks for your question. The crates planters are manufactured from 100% recycled materials, so keeping plastics out of landfill and the oceans has a lifespan in excess of 100 years and is recyclable again up to 9 times. No risk of it breaking down, as very chemical resistant and won't biodegrade or photodegrade. We understand the sentiment surrounding burying plastic and are actively researching using alternative materials. Thank you for that excellent answer, James. Next question also from an anonymous attendee. A lot of people want to do things themselves, like planting trees in their gardens, not turning front gardens into drives. Is this useful to do as well as SuDS? Another fantastic question. Thank you. Stuart McClellan replies, community involvement and actions is a very important part of building resilience. Lots of small contributions can add up to a significant impact. And I think that Rachel had sort of said that as well in a bit in her part of the presentation. And Rob goes on to say, in terms of broader scale environmental benefits, absolutely. In terms of hydrological benefits, the benefit of an individual tree is probably quite limited in spatial extent, certainly while the tree is young, but could become larger as the tree matures. But as Stuart suggests, the benefit of many trees and many different activities, oops, I've just lost the question. Apologies, bear with me. Sorry. As Stuart suggests, the benefit of many trees and many different activities often adds up to much greater than the sum of the parts. Thank you for that, Rob, and I completely agree with that. And Howard Gray goes on to say the option of diverting rainwater from roofs is inexpensive, and this water is very clean. I have diverted my downpipes to water flower beds and vegetable gardens. It doesn't need any pollution remediation. Well, that's good news. That's a great answer, thank you. And question from Mark Manning. What if you could control your water retention so it's used as a resource, RWH, but discharge water prior to a storm and do this via a smart system? Would this be of interest? I know people are looking into that at the moment, and Rob answers potentially. It would depend upon the storage volume versus the expected rainfall. If you discharge lots of retention structures at the same time to create space, you could potentially create a larger hazard than the event you were trying to make space for. So the answer is a bit nuanced. Sorry. That's all right. It's a fantastic answer. Thank you, Rob. And And Howard says, this is what Glasgow have done with the Glasgow Canals project. Okay, might have to look into that one a little bit more. Thank you. An anonymous attendee asks how well the SuDS perform in the face of heavy or torrential rain. Rob answers, as you might expect, the behavior and performance of SuDS is related to how well designed they are and how big they are. The larger the SuD, the more impact it has. The better the design, the more likely it is to work well. For example, a well-designed aquagreen could have a huge effect. A poorly designed or small volume, less than 100 liters, say, water capture system, for example, a water butt, would have less effect. Also, from Stuart McClellan, also, if SuDS don't retain all the water from a flood event, they will still slow the rate at which water flows into river channel systems, which contributes to reducing flood risk. Often, we can't stop floods, but reducing their magnitude makes it easier to manage community resilience. Thank you for that answer. And Howard Gray answers, also bear in mind that only the first 10 millimeters of runoff is actually polluted. So as long as the first flush goes via the SuD system, later volumes can pass by to other storage provision. Thank you for that. Paul Spate answers, thanks, Rob. What we find is the clay becomes less continuous as you go northwards in the Hull area. Therefore, soakaways for road drainage, for example, are not appropriate everywhere, whilst hydrocarbons are generally LNAPL, sorry, they're also effectively untreatable at water treatment works. Therefore, a precautionary approach is encouraged. Okay. And to that, Rob answers, yes, I agree with that, Paul, and particularly establishing local geological conditions before folks design and construct schemes. One size probably doesn't fit all. And I would just add to that that this is part of why we need local companies to be involved in this innovation of SuDS, because the local people will be, local businesses will be mainly focused on what we need locally, which is taking into account the geology of the area. And Howard adds, here at Green Blue Urban, we have found that almost all of the highways authorities do not allow infiltration anywhere near an adopted road, whatever the underlying geology. Okay, that's interesting. We've got some thank yous. And Bill Blackledge says, the green SuDS designers we need already exist. They are called landscape architects. And I completely agree with that. I made sure to invite as many landscape architects in the local area to this webinar, because those are exactly the kind of people that we need. And Kate goes on to say, exactly so, Bill. One of the things we want to do within the Flood Innovation Center is bring knowledge from other sectors into the flood resilience market. If you'd like to work with us, then let us know. And Bill Chun goes on to say, hi, Bill, our program aims to work with a diverse and wide range of businesses within different sectors with the ultimate aim of combating flood. And Bill says, thanks, I am, Kate. And indeed, he is. And it's nice to have your input today, Bill. Thank you. This type of system would mitigate both flooding and drought. And if you could included grey water reuse in the whole scheme, it would again reduce the amount of water in the network, reduce demand. And Stuart replies to that, this is the concept shown in the second to last slide in the talk that suggests SuDS can be used to manage water recycling as well as slowing the flow. And Mark Manning adds, asks, what if they were each connected to each other in the network in a mesh, or only discharged when the network was dry prior to a storm at 3 in the morning when there was less stress on the network? And Rachel replies, yes, that's an innovative approach we are looking for, optimizing assets so they work together and not individually. And Stuart adds, there is definitely potential for smart systems where SuDS are interconnected and optimized to reduce risk. Chun goes on to say, hi, Mark, could you please drop us an email at flick@hull.ac.uk so we can start further conversations to explore the options of working together. And that same goes for anybody who has got some innovative ideas around flood resilience. Please do get in touch. Kate goes on to add, there's so much potential both for linking interconnected solutions as well as linked technology and engineering. We'd love to work on this with a local SMA. Mark is asking if he could have the email address. I think we have just given that. However, I'll say it again. It's flic@hull.ac.uk if you would like to get in touch with us, that would be the best way to do it. Rachel has also added hers on here, rachel.glossop@hullcc.gov.uk. And I know Rachel's particularly interested in finding some local suppliers to bid for the work that the Hull City Council is putting out. And Pip adds, hi Mark, really liking the sound of these ideas. Hi, is just about to cover how to register with the project so we can continue the exploratory discussions, and I did actually go through that. So any of those ways of getting in touch are absolutely fine. So I think that is all the questions answered, unless anybody has any additional questions. Got some open questions now. Okay, Bill Blackledge again. Thank you, Bill. Are you planning to create a community of local SMEs? That is absolutely our idea. We want this sort of, like I said, this collaboration ecosystem where we have people with different areas of expertise working together to help solve this problem of flood resilience. Did anyone want to add anything to that? You can answer live.
Rachel here. So can I just
Yes,
answer that as well?
Yeah,
because what Bill said before about the landscape architects is totally right. But what we find is we have people, we almost need them joining up. So you've got the drainage engineer who can work out the volume, who can work out sort of the more traditional approach. He can look at the runoff that we're requesting on the site. He can do the micro drainage calculations, so we can work out what volume is needed, and then that almost needs to be passed on to a landscape architect to be able to create that volume within the development site. So unfortunately, at the moment, what happens is you either get one or the other, and this doesn't match up. But ideally, if we had that community of SMEs who could work together on that, that would be great, because then we'd be getting true SuDS rather than just SuDS that focus too much on flooding, or SuDS that focus too much on the sort of greener element of it, but don't address the flood element of it. The issue we have, obviously, in terms of planning is that as a lead local flood authority, if we don't get the volume of storage we need for flooding, we will object. So that's the crux of this. We need to get the volume of storage, because our systems are at capacity in Hull, so obviously we don't want new development adding to the existing flooding problem, but we don't want to carry on putting tanks in the ground and putting oversized pipes in which people can't see. We want to get the additional benefits from SuDS, and this is where SMEs and things can work together to create those.
Thank you, Rachel, for that answer. The next question is, many thanks, a very informative webinar. If we, LSTC Driftfield, can support through topographical surveys supporting designers, we would be more than happy to support. And they've given their contact details, which is info@lstc.co.uk. And likewise, Martin, if you'd like to get in touch with us to see how we could sort of put you in touch with some other people, please do, because we could probably get some mutual support and collaboration going on with that. Right, have we got any more questions today? I think we've just about exhausted them all. Oh, I've got someone, Howard, you go ahead and answer the question. Do I need to unmute you, or are you?
Go ahead, sorry.
Yeah, go ahead. Thank you, Howard. Like to answer a question. Bill has written, agree, Rachel, we need to work together with drainage engineers. Hard to find sympathetic ones. What would you like to say?
Just say, this is absolutely true what Bill's saying. As drainage, what we find in drainage engineers are very much used to pipes and ditches and sizing that, but we're finding that there is incredible appetite within the civil engineering market for learning about green options, and Green Blue Urban have actually put a lot of money into getting micro drainage, a lot of green infrastructure options onto micro drainage to make it easy. What we find is a lot of engineers just like to tap some numbers into a software program, and it just burps them out the sort of size of swale or balancing pond they need, which hasn't been very easy to do up until now, but that is actually currently being there. So we are investing in that, and that should be launched very shortly to make it like people's lives easier.
All right, thank you very much, Howard. All right, is there any more questions? If there are no more questions, then I will just move on. Just give it, oh wait, I got another one. There's always a few that come in late, a little bit later. Right, so John Payman says, hi Rachel and all. Humber Civils are local civil engineers who have the necessary micro drainage capabilities and SuDS experience, and would really welcome working with any local hydrologists and landscape architects to form a team. Would really welcome chatting further about this. Again, if you are looking for a collaboration opportunity, do get in touch, because that is very much what we do. Bill Blackledge says, "I'll be in touch," which is fantastic, and we hope to carry on being in touch with you, Bill, as well. Did anyone else want to say anything else to John Payman in way of an answer? Okay, if there's any more questions, I think we might be just about finished. Okay. So I just want to say thank you very much for joining us today. Thank you to the panel. I've learned quite a lot about sustainable drainage through this process, and I do hope that all the attendees have done so as well. Please look out for future webinars from the Flood Innovation Center. We do have some coming up that we are going to be on different topics, actually. So quite a broad range of stuff. If you're interested in flood resilience, then please do check us out via the usual channels. After this, you will receive a follow-up email that will give you a link to our YouTube channel, where you will find the videos for any of the webinars that we do. This one we'll get it up there shortly. So just check that YouTube channel now and again if you want to watch, or if you're unable to attend one of our future webinars. That's a great place to go to see if you can find it there. You will also be receiving at the termination of the webinar a survey. It's brief. It's pretty quick to fill out, and we'd really appreciate your feedback. It helps us to shape our future, shaping the future of our webinars, so that we know that we're delivering the kind of content that you would like to see in a way that is effective. Thank you very much. One last thing I'd like to say is that the registration is super easy. It's worth a try. There's no harm in filling out that initial eligibility form. You will find out very quickly if you're eligible, and if so, then you will definitely benefit from being involved in a project with Flood Innovation Center. The details, contact details for Liz Johnson, our BDM, are on the bottom of your screen. We're also, as I say, you can also find more details on the university website. Thank you so much for attending today, and have a wonderful day, and go out and enjoy the sunshine.